Integration of AI resource consumption metrics by Q2 2024, Comprehensive Report. Executive Summary. The integration of AI resource consumption metrics is a pivotal initiative set to be completed by Q2 2024. With a strategic investment of $1.8 million directed towards enhancing data analytics infrastructure. This initiative is structured into 4 key phases that aim to optimize resource utilization and improve data-driven decision-making capabilities within the organization. Phase Development Overview. Phase 1, Planning and Assessment. This foundational phase involves a thorough evaluation of the current data analytics capabilities within the organization. Stakeholders will conduct a comprehensive assessment to identify existing gaps in resource consumption tracking. The focus will be on reviewing current tools and technologies in use, identifying deficiencies in data collection and analysis, establishing a clear framework for what metrics need to be integrated to measure AI resource consumption effectively. The outcome of this phase will be a detailed report outlining the current state of analytics capabilities and a roadmap for necessary enhancements. Phase 2, Infrastructure Development. Once the assessment is complete, the project will move into the infrastructure development phase. This involves the deployment of advanced data analytics tools and technologies aimed at supporting improved tracking of AI resource consumption. Key activities will include allocating the $1.8 million investment towards upgrading or replacing outdated systems, integrating new software solutions that facilitate real-time data analysis, ensuring that the new infrastructure is scalable to accommodate future growth and evolving technology requirements. This phase is critical to establishing a robust foundation for effective data analytics and will involve collaboration with IT and data science teams. Phase 3, Implementation and Testing. Following the infrastructure build-out, the focus will shift to the implementation of AI resource consumption metrics within operational processes. This phase will encompass integrating the newly developed metrics into existing workflows, conducting rigorous testing to ensure that the metrics are accurate and reliable, gathering feedback from users to identify any issues or areas for improvement. Adjustments will be made based on the testing outcomes to optimize the integration process and ensure that the metrics serve their intended purpose effectively. Phase 4, Full Deployment and Monitoring. The final phase involves the complete rollout of the integrated metrics system across the organization. Key actions during this phase will include launching the new system organization-wide, implementing a continuous monitoring framework to track the performance of the metrics, establishing feedback loops for ongoing optimization based on user experiences and operational needs. This phase is crucial for ensuring that the investment in data analytics delivers tangible benefits and that the organization can adapt to changing demands in resource consumption. Common key points. Investment in infrastructure. The commitment of $1.8 million signifies a strong organizational focus on enhancing data analytics capabilities, which is essential for effective AI resource management. Phased approach. The structured 4-phase development plan minimizes disruptions during implementation and facilitates a smooth transition to enhanced analytics capabilities. Focus on AI metrics. The initiative emphasizes the importance of integrating AI resource consumption metrics, which will help improve operational efficiency, reduce resource waste, and promote data-driven decision-making across the organization. Differences between sources. While various sources may present specific details differently, the overarching theme remains consistent: the critical need for high-quality data and a robust analytics infrastructure to support AI initiatives. Some sources may delve deeper into technological aspects, while others might highlight strategic implications such as improved productivity and cost-effectiveness. Timeline of events. Q1 2023. Initial discussions commence regarding the integration of AI resource consumption metrics. Q2 2023, a thorough assessment of existing infrastructure is conducted identifying specific needs for improvement. Q3 2023, the allocation of the $1.8 million investment is finalized, and infrastructure development begins. Q4 2023, new analytics tools are implemented and the testing phase initiates to verify functionality. Q1 2024, final adjustments based on user feedback are made to ensure optimal performance. Q2 2024, full deployment and monitoring of the integrated AI resource consumption metrics system commence. Conclusion. The integration of AI resource consumption metrics represents a significant advancement in the organization's data analytics capabilities. By investing $1.8 million and employing a structured four-phase development approach, the organization is poised to enhance its operational efficiency and decision-making processes. This initiative not only improves resource utilization but also aligns with broader strategic goals of fostering a data-driven culture. Continuous monitoring and optimization will ensure that the system remains relevant and effective in meeting the organization's evolving needs. References. 1. ResearchGate AI Data Quality and Bias Challenges. Links www.researchgate.net/publication/3860838458 Data Quality and Bias Challenges Implications and Solutions in Modern Machine Learning. This comprehensive report provides a detailed overview of the integration initiative, highlighting its significant structured approach and anticipated outcomes by Q2 2024. The document outlines a strategic initiative for integrating AI resource consumption metrics featuring a structured approach that includes a significant investment in data analytics infrastructure. Here are the counterintuitive insights derived from the content. 1. High initial investment for long-term gains. While a $1.8 million investment may appear excessive at first glance, especially for organizations with limited budgets, it is counterintuitive to consider this as a long-term cost-cutting measure. Investing upfront in data analytics infrastructure can lead to substantial savings by optimizing resource utilization and minimizing waste over time, which contradicts the common notion that cutting costs immediately is always the best strategy. 2. Phased implementation as a risk mitigation strategy. The phased approach may seem like it would slow down the process of integration, but it actually serves as a risk mitigation strategy. Many organizations rush to implement new systems, leading to potential failures and wasted resources. By breaking the process into phases, the organization can learn and adapt at each stage, leading to a more successful outcome, contradicting the belief that speed is always advantageous in project execution. 3. Focus on AI metrics for efficiency. It might seem counterintuitive to focus on AI resource consumption metrics specifically, as many organizations may prioritize overall efficiency improvements instead. However, by honing in on AI metrics, the organization can uncover unique insights and inefficiencies related specifically to AI operations, which can be overlooked when evaluating broader efficiency metrics. This targeted approach may yield higher returns on investment than a generalized efficiency strategy. For continuous monitoring over initial success, the emphasis on continuous monitoring and optimization may appear excessive after full deployment, as many believe that once a system is up and running it should be left alone. However, ongoing monitoring is essential to adapt to changing operational demands and to ensure that the system continues to perform effectively, challenging the assumption that stability equates to success without further intervention. 5. Importance of data quality over quantity. The project underscores the necessity of high-quality data rather than a sheer volume of data, which may seem contrary to the common trend of accumulating large datasets. Quality data is more critical for accurate AI performance, and focusing on data integrity can lead to better decision-making outcomes, countering the prevalent belief that more data is always better. 6. Stakeholder assessment as a foundation for success. The initial phase emphasizes stakeholder assessment, which may seem like a bureaucratic step that could delay progress. However, engaging stakeholders early ensures that the integration aligns with actual operational needs and challenges. leading to a more effective implementation. This counters the assumption that technical teams can solely drive successful projects without stakeholder input. These insights reveal that the project's approach to integrating AI resource consumption metrics is nuanced and challenges several conventional beliefs regarding investment implementation speed, data handling, and stakeholder involvement. By understanding these counterintuitive aspects, organizations can better appreciate the strategic value of the initiative. The report on the integration of AI resource consumption metrics is crucial for understanding how organizations can leverage data analytics to optimize their operations. However, several significant aspects may be overlooked by many readers. Here's an in-depth examination of these elements and their importance. 1. Investment justification and long-term value. While the $1.8 million investment in data analytics infrastructure is highlighted, the implications of this investment extend beyond immediate expenditures. Organizations often underestimate the long-term value that enhanced analytics capabilities can bring. This investment not only aims to improve current operations but also positions the organization to better adapt to future technological advancements and market changes. Significance: the ability to adapt to evolving data landscapes and AI technologies can significantly enhance competitive advantage. Companies that prioritize robust analytics infrastructures will likely see improved decision-making capabilities, leading to better resource allocation and cost savings in the long run. 2. Phased approach and risk mitigation. The structured four-phase approach is essential for minimizing disruption during implementation. Many may overlook how critical this systematic development is in managing risks associated with technology integration. Each phase serves as an opportunity to assess progress and make necessary adjustments before moving forward. Significance: by breaking the project into manageable phases, organizations can identify potential problems early, reducing the risk of costly failures or delays. This methodical approach also fosters stakeholder engagement and buy-in at each stage, ultimately leading to a more successful implementation. 3. Emphasis on continuous monitoring and adaptation. The final phase of the project involves continuous monitoring and optimization, which is often a neglected aspect in many technology integration reports. While the initial implementation is important, the ongoing evaluation and adjustment of the AI metrics are critical for sustained success. Significance: continuous monitoring ensures that the metrics remain relevant and effective as operational needs change. This adaptability is crucial in a rapidly evolving AI environment where static systems can quickly become outdated. Organizations that prioritize this aspect will be better equipped to respond to new challenges and opportunities. 4. Collaboration across departments. The integration of AI resource consumption metrics requires collaboration among various stakeholders, including IT operations and finance. The report does not explicitly mention this collaborative aspect, which is vital for successful implementation. Significance: effective collaboration can lead to a more holistic understanding of resource consumption across the organization. Different departments can provide unique insights that enhance the overall analytics framework, ensuring that the metrics developed are comprehensive and actionable. 5. Data quality and governance challenges. The report implicitly touches on the need for robust data quality and governance but does not delve deeply into these challenges. Many organizations overlook the significance of high-quality data in the successful integration of AI metrics. Poor data quality can lead to inaccurate analytics and misguided decision-making. Significance: organizations must establish strong data governance frameworks to ensure data integrity, accessibility, and security. Addressing data quality challenges upfront can prevent costly errors and enhance the reliability of the AI resource consumption metrics developed. 6. Strategic alignment with organizational goals. Integrating AI resource consumption metrics should align with broader organizational goals. The report mainly focuses on the technical aspects and investment without emphasizing how this initiative supports the strategic objectives of the organization. Significance: ensuring that the integration aligns with the company's mission and vision can foster greater acceptance and utilization of the new systems. When stakeholders understand how the project contributes to overarching goals, they are more likely to support its implementation and integration into daily operations. 7. Potential for enhanced sustainability practices. While the report mentions optimizing resource utilization, it does not explicitly link this to broader sustainability efforts. Many organizations are increasingly focused on sustainability and reducing their environmental impact. Significance: optimizing resource consumption through AI metrics can directly contribute to sustainability initiatives by identifying areas for waste reduction and more efficient resource use. Organizations that capitalize on this potential can enhance their corporate social responsibility profile and meet regulatory demands, which is becoming increasingly important to stakeholders. 8. Scalability of analytics infrastructure. The report outlines a robust investment in data analytics but does not emphasize the importance of scalability in the analytics infrastructure. As organizations grow and evolve, their data needs can change significantly. Significance: building a scalable analytics infrastructure ensures that the organization can accommodate increasing data volumes and complexity without requiring substantial additional investments. Scalability is key to future-proofing the investment and maintaining agility in decision-making processes. Conclusion: the integration of AI resource consumption metrics by Q2 2024 is a multifaceted initiative with significant implications for organizations. While the report provides a structured overview of the planned phases and investment, it is crucial to recognize and address the often overlooked aspects such as long-term value risk mitigation through phased approaches, the importance of collaboration, and the need for data quality and governance. By focusing on these critical elements, organizations can ensure that their investment in AI and data analytics infrastructure leads to meaningful improvements in efficiency, decision-making, and overall operational effectiveness. 1. Investment in data analytics infrastructure. The commitment of $1.8 million to enhance data analytics capabilities is a crucial point. This investment signifies a strategic prioritization of data-driven decision-making and operational efficiency. By upgrading existing systems and integrating advanced analytics tools, the organization aims to optimize AI resource consumption, reduce waste, and ultimately improve profitability. A discussion surrounding the expected ROI from this investment, potential risks, and how it aligns with broader organizational goals would be valuable. 2. Phased development approach. The structured four-phase approach: planning and assessment, infrastructure development, implementation and testing, full deployment and monitoring, is essential for systematic development and minimizes operational disruptions. This phased strategy allows for iterative feedback and adjustments, ensuring that the final metrics system is robust and tailored to the organization's needs. Analyzing the benefits of such a phased approach versus a more rapid, less structured implementation could provide insights into best practices for similar initiatives. 3. Integration of AI resource consumption metrics. The focus on integrating AI resource consumption metrics reflects a growing recognition of the importance of measurable performance indicators in technology operations. This integration aims to enhance efficiency and support data-driven decision-making. A deeper analysis of how these metrics will be defined, measured, and utilized could lead to discussions about best practices, potential challenges in implementation, and the implications for workforce training and change management. 4. Continuous monitoring and optimization. The emphasis on continuous monitoring and optimization in the final deployment phase highlights the need for adaptability in data analytics systems. As operational demands evolve, the metrics system will need to adjust accordingly. This point opens up discussions about the importance of feedback loops, real-time data analytics, and the role of machine learning in refining the accuracy and relevance of AI resource consumption metrics over time. Exploring how organizations can establish a culture of continuous improvement in data analytics could yield practical insights for similar projects. 1. The Manhattan Project 1942 to 1946. This was a research and development project during World War II that produced the first nuclear weapons. The project was initiated in response to fears that Nazi Germany would develop atomic bombs. It involved a massive investment in infrastructure and technology, including the construction of large-scale facilities for uranium enrichment and plutonium production. The project was divided into several phases, including theoretical research, experimental work, and production. The successful testing of the atomic bomb in July 1945 marked a significant technological achievement and had profound implications for warfare and international relations. 2. The Apollo Program 1961 to 1972. This was a series of space missions conducted by NASA with the goal of landing humans on the Moon and bringing them safely back to Earth. The program involved extensive planning and investment, with a total expenditure of approximately $25.4 billion, equivalent to over $150 billion today. It was executed in multiple phases, including unmanned test flights, manned missions, and lunar landings. The Apollo 11 mission in 1969 successfully landed the first humans on the Moon, representing a monumental achievement in space exploration and technology. 3. The Human Genome Project 1990 to 2003. This was an international scientific research initiative aimed at mapping and understanding all the genes of the human species. It involved numerous countries and institutions, with a total investment of around $3 billion. The project was organized into several phases, including the mapping phase, sequencing phase, and analysis phase. The completion of the Human Genome Project in 2003 provided critical insights into genetics, paved the way for advances in personalized medicine, and transformed the field of genomics. Future outlook: predictions for the integration of AI resource consumption metrics by Q2 2024. The integration of AI resource consumption metrics represents a pivotal advancement in the field of data analytics and AI management. With a structured investment of $1.8 million and a phased approach to development, the implications of this initiative are far-reaching. Below are key predictions regarding the future outcomes and impacts of this integration by mid-2024 and beyond. 1. Enhanced decision-making capabilities. By the completion of the integration process in Q2 2024, organizations can expect significantly improved decision-making capabilities. The implementation of refined AI resource consumption metrics will allow for real-time insights into resource usage. This data-driven approach will enable organizations to make informed decisions, quickly optimizing operational efficiency and reducing waste. Anticipated outcomes include faster response times to market changes and better alignment of resources with business goals. 2. Increased operational efficiency. The structured four-phase development process will lead to operational efficiencies as organizations streamline their resource management. With advanced tracking and analytics tools in place, companies will be able to identify inefficiencies and bottlenecks in their AI operations. Consequently, organizations can expect a measurable reduction in resource wastage, potentially leading to cost savings estimated at 15 to 20% in resource-related expenditures within the first year of full deployment. 3. Improved data quality and reliability. As organizations focus on refining their data analytics infrastructure, a heightened emphasis on data quality will emerge. The integration of AI resource consumption metrics will necessitate the adoption of robust data governance practices. By Q2 2024, businesses can expect enhanced accuracy and reliability in their data, which will not only facilitate better internal decision-making but also improve stakeholder confidence in reported metrics and outcomes. 4. Integration of advanced analytics and AI. Post-deployment, organizations will likely begin to incorporate more advanced analytics techniques such as predictive analytics and machine learning algorithms into their resource consumption metrics. This evolution will enable proactive resource management, forecasting future needs based on historical data trends. By 2025, it is predicted that a significant number of organizations will leverage these capabilities to preemptively address potential resource shortages or surpluses, further enhancing operational agility. 5. Competitive advantage through innovation. As companies adopt these advanced metrics and analytics capabilities, a competitive edge will emerge for those who effectively utilize the data generated. Enterprises that successfully integrate AI resource consumption metrics will likely experience accelerated innovation cycles, leading to the development of new products and services tailored to consumer demands. By mid-2025, it is expected that organizations utilizing these insights will outperform their competitors in both market share and profitability. 6. Greater emphasis on sustainability. The focus on optimizing resource consumption will inherently promote sustainability initiatives within organizations. As metrics reveal consumption patterns, companies will be better positioned to implement sustainable practices that reduce their environmental footprint. By Q2 2024, organizations may begin to publicly share their sustainability metrics, aligning their corporate social responsibility goals with operational practices, thereby appealing to a growing consumer base that prioritizes sustainability. 7. Evolution of workforce roles. The integration of AI resource consumption metrics will also impact workforce dynamics. As reliance on data analytics increases, roles will evolve to include data analysts and data scientists who specialize in interpreting these metrics. By 2025, organizations will likely see a demand for new skill sets focused on data analysis and AI management, prompting a shift in training and hiring practices to cultivate a workforce adept in these areas. 8. Enhanced collaboration across departments. The initiative is set to foster better collaboration between IT operations and strategic planning departments. With access to standardized metrics, cross-departmental teams can work together more effectively to align resources with organizational objectives. By mid-2024, organizations may experience improved synergy in project execution and resource allocation, ultimately leading to greater overall performance. 9. Challenges and adaptations. While the outlook is promising, challenges such as data integration complexities and the need for cultural shifts within organizations must be acknowledged. Resistance to change can hinder the adoption of new technologies, and organizations will need to actively manage this transition. By Q2 2024, it is expected that successful organizations will have implemented change management strategies to address these challenges head-on, ensuring a smoother transition and greater acceptance of new systems and processes. Conclusion. The integration of AI resource consumption metrics by Q2 2024 is anticipated to revolutionize how organizations manage resources, leveraging data analytics to drive efficiency, sustainability, and innovation. As businesses navigate this shift, those that effectively embrace these changes will likely emerge as leaders in their respective industries, harnessing the power of data to fuel growth and respond dynamically to market demands. The future holds exciting potential for organizations that strategically invest in their data analytics infrastructure and commit to a culture of continuous improvement.